Good morning. Today we are going to see the problems which we have in unit test 1. So now in this we have first problem, derive stress block parameters. So we will start with first stress block parameters. So we have this diagram that is given in IS code. If we will go to IS code, then we have this diagram. Page number, I will just mention page number of this, that is 69. Then using this diagram, we have to go for stress block parameters. This question was asked for 5 marks. So page 69. So we have area of stress diagram. So we have that is area of rectangle. So divide it into two parts. So first part we have that is area of rectangle. This is first part and this is second part, area of parabola. Area of rectangle we know that is width into height. So 0.45 FCK into 3 by 7 XU. In some book, if you will see, you have this value as 0.446 FCK, it's okay. Plus, we have parabola 2 by 3rd base into height, so 2 by 3.45 FCK into 4 by 7 XU. And we will get the total compressive force per millimeter because we are not multiplying it by width, so it will be per millimeter. Means we have this unit of this force is Newton per millimeters. And then plus this first value is 0.193 FCK XU, second 0.171 FCK XU, and this total B, if we will consider it will be Newton, then we have to consider B over here also. So without B, we have this value Newton per millimeters. And this value generally taken as 0.36 FCK XU into B. So we have 3 marks till this with diagram. Then we have to go for position of this compressive force. Then we have this diagram. Then summation A x bar. We know centroid how we will find. So x bar is summation A x bar upon summation A. So we have calculated value of this rectangle force 1.193 FCK XU into B. You can multiply by B or you cannot be. Then center of this. So we have 1/2 because we have this as rectangle. So 1/2 3/7 of XU plus value of parabola also we have calculated area we have 0.176 FCK XU and then we have CG of this from base. So from here we have this value that is 3/8 of 4/7 XU, but we have to find from top. So we have to add this value of 3/7 of XU and then divide by total area which we have calculated 0.36 FCK XU B. So we have this value 0.36 FCK XU into B. And that will give us 0.416 XU, approximately 0.42 XU. So we have this for 2 marks. So total we have for 5 marks this question 1A. Now we will switch over to the second question. Determine the moment of resistance of a beam 275 mm wide and we have 415 mm effective depth. You have to keep in mind what is given. So effective depth is given means D is given. So 6 bars of 20 mm diameter on tension and 6 bars of 16 mm on compression side. M20 and Fe415. So you have to draw first diagram. Values are given. B value is given, that is 275. Value of D is given 415. Then we have this as 6 bars. So we have 6 bars here, that is of 20 torque, and that is tension AST. And we have ASC, that is again 6 bars of 16 torque. So 16 torque. So this is ASC. Then we have to assume KU. These steps already we have seen yesterday. So calculate AST when we have 682.76 millimeters square. Then AST minus ASC we have 678.59. then we have AST minus ASC upon AST1. We have this value that is 0.3 and then epsilon SC. So KU1 we have this. Now our first trial starts. Mark you will get from this portion. So we have epsilon SC 0.0035. Then from this we will get value 0.00238. And then now assume FSC we have 341. So we have 2 marks for first trial. Then we will switch over to the next part. We have XU. We have calculated XU 135.96 millimeters. So we are going to find out XU for epsilon SC for this XU value. If we will substitute the values, then we will get value 0.00247. And now for this value 0.00247, we have to calculate value of FSC. So we have taken this value 0.00241 and then 0.00276. Against this, we have these values of FSC. So we have interpolated value FSC and we got this value, that is FSC equal to 344.34 Newton per mm square. See, value assumed is 341 and now we got value as 344.34. So we have marks for this, that we have 3 marks for this. So we have 10 marks problem. So assume FSC 344 Newton per mm square. And if you will calculate value of XU, then we have 134.13. And then epsilon SC, we will get it as 0.00246. And against this, because we have 0.00247, value we got 344.34. And for 0.00246, we can consider values 0.344.3. I have deleted this 4 because these two are very close. And then we have this will be for 2 marks. So we have 7 marks till this. Then we will find MR. So we know for first that is CU1 into lever arm plus CU2 into lever arm. And then we will substitute the values. And by substituting these values, we are going to get moment of resistance, and that is equal to 251 kilonewton meter. And then we have, so we have 3 to 5 to 7 and remaining 3 marks we have for moment of resistance. So we have marking scheme in this fashion. So we have these 10 marks for question 1B. Now we will switch over to the question 2A. Now this is given a RCC rectangular beam is 250 mm wide and 550 mm deep. Calculate moment of resistance of a balanced section. And characteristic strength of concrete is 27 and that is of steel is 450. Effective cover is given 40. So we have formula for KU max 0.0035 upon 0.0055 plus 0.87 Fy upon 2 into 10 raised to 5. So this formula is depend only on Fy. So from this we will calculate value that is KU max. So we have value of KU max. If we will calculate, you have this value that is equal to 0.47. So for this value, I will get 2 marks. Then I will go for XU max. So for XU max, we have 239.7 millimeters. So I have 2 marks for this. And then we will go for MR. So MR we have 0.36 FCK XUB D minus 0.42 XU. We will substitute the values, and by substituting value, I will get value of MR that is 238.42 kilonewton meters, and we have this will be for 3 marks. So we have this question that is for 7 marks, 3 plus 2 plus 2, and then we have that is 7 marks. Now we will switch over to the question 2B. Now we have T sections. So we are going to assume neutral axis in flange and then we will find value of XU. This question was asked for 8 marks. So we have first these marks we will get 1 CU equal to TU. Then we will calculate XU. Then we will have this value that is 2 marks. And then as it is in flange, and then we are going to get MR directly. So we have, that is again 1 marks for this. Then we have, substituting all these values, then we are going to get 356 kilonewton meter. So we have 4 marks for this. Sometimes this such happens. So you have neutral axis in flange, and this question becomes very easy for 8 marks. So depending upon the problem, we have this value that is of MR. So these are the questions which are in new unit number 1. So now we will stop here only. Remaining part we will see in the next video. Thank you.